this lecture, we will be going through how to access any peripheral register of a microcontroller using structure and union. So this will be useful in many different scenarios. One of the scenarios, the example what I am showing here is a PIC microcontroller, and what I'm highlighting here is a port A register, a GPIO register. So in port A, you have kind of like pins up to six pins, and say like you want to toggle you want to toggle each pin based on different inputs or at different time intervals. So like or you want to toggle multiple pins, a combination of pins on different intervals. So what you do is, so I'm going to show a simple C program how you can do all of this. So now what I'm sharing is a simple C program. So here I have a union which maps all the bits in register port A. So port A is our register, and in port A you have RA0 to RA5, and bit 6 and 7 is reserved. If you see the data sheet, so bit 6 and 7 is reserved. So this mapping is done through a structure. So this structure is wrapped inside a union. So this union is what we are going to access. This union is a union called port register, port A, and this union has two members. One is a structure and other is a variable itself. It's just one byte variable. So you can say like if you want directly to access the all the pins or modify all the pins, you can directly access the port value variable to modify all the status of the bits in a one go. But if you want to modify only a specific bits or 3 or 2 bits, so you can use this structure member inside the union. So since union size of the union is the largest data type, so the largest data type will be only uint8, because the structure uses only bit field. So this is 1 byte, and the structure is 1 byte, and the memory occupied by the port value is also 1 byte. So the largest union is always 1 byte, which is 8 bits. Let us go to the main of this function. So now register port A is our union, where the port value I have given some random value, which is so 5 2. So the LSB2 is used to set bit 1, and the MSB5 which will set both bit 6 and 4. So what I say is, if you want to write value that one shot goes or writes all the bits in this port A register, you can use port value, which is a member of the union. Now, and next I am calling print to port A bits. So once let us see how this is changing each bits. Now when I so here this print function will print all the bits in the port A register. Let's run this program. Control F5 to run. Now if you see here, the output is displayed on the terminal. Now if you see RA1 and RA4, so the pin 1 and 4 are set to high. So this is reserved bits, just don't care. So just for a demonstration I have written this. Now let us say you want to access only bit 1. So to access only bit 1 of the port A, what we do traditionally is port A value is without changing the bits of with other bits in this port A. What do we do generally? You just AND it and equal to, so if you want to change only bit 1 x02, I want to make it as bit 1 is set. Now I am going to clear only bit 1. Now let us print all the values. So other bits should be unchanged. I'm building this program. Now you see bit 1 is clear. Other bits remains unchanged. So you cannot do this in many places, and if you it is like you have to define a macro, or it's you it your code, you have to take a little bit of effort to understand this code what you're doing. So in a simple way, this can be written as, let us do one more way. Access port A. So port A has two members. We are going to access pins. In pins, you want to change only one. So this will change only to 0. Now let us examine the values. Let's compile the program. So what happened here? So, and it is while seeing the code, it is clear that you are only making the pin 1 to high or low in this case. So this is readable. Let me show one more scenarios like this. Example. So if I equal to, no need I, let us take some other different kinds of scenarios where you see, yeah, so sleep, let us take some use some sleep delay. Okay. Sleep of 1 millisecond. Okay, let's continue. To add sleep, you have to add unisted.h. I just added that, and I'm going to show different scenario where these kinds of structure and union will be useful. But this is very simple program. I'm just showing it with the GPIO, but in real scenario, assume you're doing a different kind of protocol communication using UART or I2C, and your application has a different state machine based on the communication data arrived, and you want to handshaking between the host or your application. You can implement these kinds of structure and union for your state machines. So let us say here, after a sleep of 1 millisecond, I want, so example, so let us initialize all the pin values are low. We don't want this example now. So after 1 millisecond, I just want only port 1 to be high. Yes, pin 1 to be high. After 10 milliseconds, I want port 1 and port 0 to be high, 0 and 1 to be high. So after 20 milliseconds, I want port 0 to be high and port 1 to be low. So other ports are all to the initialized state, which are all low. So let us say after some 30 milliseconds, so I need some n number of ports to be high, port 7 or 9, port, sorry, there is no 7, port 5, port 3 to be high. Can change, modify different as a however you want. So this gives you a readability. Now at last, at the end of the program, I just want all the pin values to be high. Equal to ff, and that's it. So now here you go. So after 10 milliseconds, what I want is, I want only pin 0 1 to be 1. After 20 milliseconds, pin 0 and 1, I want to change the state of pin 0 and 1. So after 10 millisecond, what happens, pin 1 and pin 0 both are high. So now at 20th millisecond, pin 0 is high and pin 1 I made it to low. Now at 30th millisecond, all your pin 0 and 1 I'm just changing, so the different states here, I'm additionally adding pin 3 as 1. So then after some 100 milliseconds, let us make all the pins to high. So this is one way of adding all the pin values without changing the values of the other pins. So let us talk about where different kinds of scenario. This is a simple GPIO toggling, but say you have an UART, TX and an RX. So when you get an RX, based on the input data, you may want to change your state machine internally and say, so once you receive the data, you want to do some stuff, and then the stuff, you're waiting for that stuff to complete. In the meantime, you will transmit another data saying, I'm waiting for so and so state. And when the state is done, you need to clear the bits. Example, you have some read state. It's just I want to explain this scenario. Read, write, error, error, or wait, different kinds of states. So you are communicating between two different systems, and you want to use some kinds of different handshake mechanism that you have designed yourselves. So in those kinds of status, scenarios or different peripherals where you want to store the status of the peripherals and you want to communicate it later. So example in your TXR is internally you may have read, write and error. So when you do read you might set the read, when you do write you might, or read or write you might do parallelly. During the read there might be an error bit. So to maintain all these states, you so these will be, this kind of structure and union mechanism will be readable, legible, it will improve. So after some months if you see the code, it will be very easy for you to understand instead of using some macros and values to just modify the bits using and or operations. This will make your code readable and more understandable, and it is easy to change different bits or values.